What I'd like to introduce you to in this video is the idea of a linear equation. And just to start ourselves out, let's look at some examples of linear equations. So for example, the equation y is equal to 2x minus 3. This is a linear equation. Now why do we call it a linear equation? Well, if you were to take the set of all of the xy pairs that satisfy this equation, and if you were to graph them on the coordinate plane, you would actually get a line. That's why it's called a linear equation. Let's actually feel good about that statement. Let's plot some of the xy pairs that satisfy this equation, and then feel good that it does indeed generate a line. So I'm just going to pick some x values that make it easy to calculate the corresponding y values. So if x is equal to 0, y is going to be 2 times 0 minus 3, which is negative 3. And on our coordinate plane here, we're going to move 0 in the x direction, 0 in the horizontal direction, and we're going to go down 3 in the vertical direction, in the y direction. So that's that point there. If x is equal to 1, what is y equal to? Well, 2 times 1 is 2 minus 3 is negative 1. So we move positive 1 in the x direction and negative 1 or down 1 in the y direction. Now let's see, if x is equal to 2, what is y? 2 times 2 is 4, minus 3 is 1. When x is equal to 2, y is equal to 1. And hopefully you're seeing now that if I were to keep going, and I encourage you to, if you want, pause the video, try x equals 3 or x equals negative 1 and keep going, you will see that this is going to generate a line. And in fact, let me connect these dots and you will see the line that I'm talking about. So let me see if I can draw. I'm going to use the line tool here. Try to connect the dots as neatly as I can. There you go. This line that I have just drawn, this is the graph. This is the graph of y is equal to 2x minus 3. So if you were to graph all of the xy pairs that satisfy this equation, you are going to get this line. And you might be saying, hey, wait, hold on, Sal. You just tried some particular points. Why don't I just get a bunch of points? How do I actually get a line? Well, I just tried integer values of x, but you could try any value in between here. All of these, it's actually a pretty neat concept. Any value of x that you input into this, you find the corresponding value for y, it will sit on this line. So for example, if we were to take x is equal to, actually let's say x is equal to negative 0.5. So if x is equal to negative 0.5, if we look at the line when x is equal to negative 0.5, it looks like y is equal to negative 4. That looks like that sits on the line. Well, let's verify that. If x is equal to negative, I'll write that as negative 1/2, then what is y equal to? Let's see, 2 times negative 1/2. I'll try it out. 2 times negative 1/2 minus 3. Well, this is 2 times negative 1/2 is negative 1 minus 3 is indeed negative 4. It is indeed negative 4. So you can literally take any x value that you put here and the corresponding y value, it is going to sit on the line. This point right over here represents a solution to this linear equation. Let me do this in a color you can see. So this point represents a solution to the linear equation. This point represents a solution to the linear equation. This point is not a solution to the linear equation. So if x is equal to 5, then y is not going to be equal to 3. If x is going to be equal to 5, you go to the line to see what the solution to the linear equation is. If x is 5, this shows us that y is going to be 7. And it's indeed that's indeed the case. 2 times 5 is 10, minus 3 is 7. The point 5, 7 is on, or it satisfies this linear equation. So if you take all of the xy pairs that satisfy it, you get a line. That is why it's called a linear equation. Now, this isn't the only way that we could write a linear equation. You could write a linear equation like, let me do this in a new color. You could write a linear equation like this. 4x minus 3y is equal to 12. This also is a linear equation. And we can see that if we were to graph the xy pairs that satisfy this, we once again get a line, x and y. If x is equal to 0, then this goes away and you have negative 3y is equal to 12. See, if negative 3y equals 12, then y would be equal to negative 4. 0, comma, negative 4. You can verify that. 4 times 0 minus 3 times negative 4, well, that's going to be equal to positive 12. And let's see, if y were to equal 0, then this is going to be 4 times x is equal to 12. Well, then x is equal to 3. And so you have the point 0, comma, negative 4, 0, comma, negative 4 on this line. And you have the point 3, comma, 0 on this line. 3, comma, 0. Did I do that right? Yep. So 0, comma, negative 4, and then 3, comma, 0. These are both going to be on this line. 3, comma, 0 is also on this line. So this line is going to look something like, I'll just try to hand draw it, something like that. So once again, all of the xy pairs that satisfy this, if you were to plot them out, it forms a line. Now, what are some examples of, maybe you're saying, well, isn't any equation a linear equation? And the simple answer is no, not any equation is a linear equation. I'll give you some examples of nonlinear equations. So a nonlinear, whoops, I need to write a little bit neater than that. Nonlinear equations. Well, those could include something like y is equal to x squared. If you graph this, you will see that this is going to be a curve. It could be something like x times y is equal to 12. This is also not going to be a line. Or it could be something like 5 over x plus y is equal to 10. This also is not going to be a line. So now, and at some point, I encourage you to try to graph these things. These are actually quite interesting. But given that we've now seen examples of linear equations and nonlinear equations, let's see if we can come up with a definition for linear equations. One way to think about it is it's an equation that if you were to graph all the x and y pairs that satisfy this equation, you'll get a line. And that's actually literally where the word linear equation comes from. But another way to think about it is it's going to be an equation where every term is either going to be a constant. So, for example, 12 is a constant. It's not going to change based on the value of some variable. 12 is 12. Or negative 3 is negative 3. So every term is either going to be a constant, or it's going to be a constant times a variable raised to the first power. So this is the constant 2 times x to the first power. This is the variable y raised to the first power. You could say this means this is just 1y. We're not dividing by x or y. We're not multiplying, or we don't have a term that has x to the second power, or x to the third power, or y to the fifth power. We just have y to the first power. We have x to the first power. We're not multiplying x and y together like we did over here. So if every term in your equation on either side of the equation is either a constant, or it's just some number times x, just x to the first power, or some number times y, and you're not multiplying your x's and y's together, you are dealing with a linear equation.